Hey, welcome to NASA Edge.
An inside and outside look at all things NASA.
Hey, that was a great job.
What's that?
Not bad.
Hey.
You know, that wasn't the plan. What's going on?
Oh, really?
No, the rule is the person who's in the chair closest to the center is the co-host for the show.
So,
There you go.
you know, it's
You've been
magic.
superseded, Blair.
Well, that's won't be the first. Yeah, it's signing. No, that's signing in, not
See?
signing
Well,
off.
see, but your job is to introduce the special co-host for
Well,
the show.
today is our Magnetospherence show,
Okay.
or Sun Earth show,
Okay.
however you want, if you don't mind, the Magnetospherence.
mind.
2008.
2008. But what we're going to be talking today primarily is about solar power and, of course, Solar Week, which Troy is going to help us with. But first, I'm very happy Troy's here for it. We're going to do Franklin's news segment.
Hey Troy, I'm glad you're here because I came across this story on the NASA website about a solar flare, solar storm. So I'm gonna, tell you about it and then get your point of view on it.
Let's talk.
The most intense burst of solar radiation in 5 decades accompanied a large solar flare on January 20th, 2005, shaking space weather theory and highlighting a need for new forecasting techniques. Similar probably to the magnetosference that you experienced during your cache.
Precisely.
In Chesapeake, Virginia.
Yeah, that was. But did you say 2005?
05.
Wow. Okay.
Yeah.
In recent history.
Right, that's right.
Relatively speaking.
That's right.
Yeah, hot news.
There you go.
The solar flare occurred at 2 a.m. Eastern Standard Time, tripping radiation monitors all over the planet and scrambling detectors on spacecraft within minutes. It was an extreme example of a flare with radiation storms that arrived too quickly to warn future interplanetary astronauts. My question to you, Troy, is a storm of this magnitude or a flare, how fast does a flare leave the sun and make it to Earth?
Generally, it takes about, from the time we see the flare, which the light from that flare or coronal mass ejection that happens, takes about 8 minutes, a CME.
Right.
It takes about 8 minutes for us to see that on Earth. However, that's a great indicator because that gives us usually up to 3 days before the plasma and the energy from that storm actually impacts the Earth in the magnetic field.
Creating magnetosference.
And that's the satellites that help us out. They give us the early warnings.
Absolutely.
Right.
Sometimes they're our first indicator of the severity or if the storm is actually in a direction that's going to have an effect on Earth.
Okay.
Well, one of the big indicators that there's serious magnetospherence going on is the aurora.
I was actually in the air when that storm.
Is that right?
Yes, and I was looking out of the airplane. We were down in crossing over from Pennsylvania over into Maryland, and I looked out the plane and out the window. I was like, man, it's bright out here. And I saw the color. It's just like,
We didn't believe him. We were like, you're not going to see Aurora flying near Pennsylvania from a commercial flight. You must have had like the free drink or something.
But the problem with that is the fact that if we actually had astronauts on the lunar surface, in their unpressurized rover away from the base camp, that proton radiation would have went right through the suits and it would have been a big problem.
That's a really good point.
Yeah.
We've been very fortunate, especially in the early days of space travel, to have gone up between solar storms or around the solar storms. They knew of solar activity, and of course in those days, but not to the extent that we do now.
Right.
Now we really can predict and forecast space weather in a much better way than we ever could before.
And as we journey back to the moon, Mars, and beyond, one of the biggest concerns that we have is going to be that the radiation effects, not only from the sun, but also galactic cosmic radiation.
That's right. Imagine taking, 6 months to get to Mars.
That's right.
In that time, you're certainly going to have solar storms during a solar cycle, or especially if you're in what's called solar maximum, when the sun is really, really active. As a matter of fact, we're headed towards that right now.
In fact, that's why the show is so important today, because we're going to be talking about the sun and solar energy. And we know that there's detrimental effects from the sun, but there are also some benefits too from the sun, which we'll talk about.
Right, but also it's important because as an insider and soon to be media nut, that's why my role as Space Weather Action Center expert really comes into play. Now, today I've set up a special Space Weather Action Center report, and the specialty is that I've decided to power the entire event by solar means.
That's your second edition, right?
Yes, my second edition. So I've set up some solar powers, and in fact, I did something else. I went so far as to create a control using exercise bikes, sort of to compare. So I've got this whole thing set up, and hopefully before you go, but if not, shortly thereafter, we'll have a Space Weather Action Center report right here today, giving you valuable information. So if you're on the moon or planning to go, you don't get caught in some unfortunate radioactive activity.
If you take a bike to keep it powered up.
Yeah, he thinks he's Lance Armstrong.
I'm hoping,
I was thinking the same thing.
That's the control. That's the control. I just want to be able to compare how well I can power it via solar energy versus.
Well, I tell you what. Let's take a break.
Power.
Let's take a break because I know you have a lot of work to do to get that ready.
I'm monitoring.
Hey, you're watching NASA Edge.
An inside and outside look at all things NASA.
Cool.
What is it with the? That's my line.
You're not in this. You're not in the seat. Don't worry
I'm not
about
in the seat, but
it.
he didn't say it that time either.
I need a cue card. I'm sorry.
Jumped over to Franklin. All right.
Welcome back to NASA Edge.
An inside and outside look at all things NASA.
See, it just seems so natural when Troy says it, doesn't it?
It does seem natural.
Hey, what about
and
me,
that's
man?
disturbing.
Well, you're always good.
You're the standard.
Hey, tell you what, we have a special guest on the line today.
Yes, we do.
We have Paulette Lever from Jet Propulsion Laboratory, or JPL. Paulette has a cool piece of technology that involves the sun directly, indirectly. We'll let her explain, and that's on solar sails.
Solar sails. Is that like when you get a discount on something? Is it...
The wrong sale.
A blue light special.
Paulette,
Not
could you explain to Blair the whole idea of solar cells and what they're all about?
You can use the radiation that comes from the sun to propel a spacecraft. And to do that, you have to put up a great big sail. We call it a solar sail. It's a shiny material, very shiny aluminum or something like that reflects the sunlight. And just the fact that sunlight is being reflected off that shiny sail gives a push on the sail. And you can use that to propel a spacecraft.
So it's not solar wind.
No, it's not using the solar wind. The solar wind is a constant stream of particles coming from the sun, but it's too weak. It has much, much less energy.
Okay, it's weak, but it also creates issues here on Earth, even though it's very weak. But that's a radiation issue, not a power issue, so to speak. Is that right?
We definitely feel its effect at Earth.
Yeah, magnetospherence.
Magnetospherence, right.
That's my word, by the way. You can use it in any publications that you...
The solar cells have been around, the concept has been around for a long time, right?
The concept's been around for a long time. Unfortunately, NASA has not yet tried to do a mission or even demonstrate the technology.
Now, is the concept of solar sails, would that just be used in the inner planets, or could you use that solar cell technology as you go beyond Mars and head towards the outer planets?
Well, actually, one of the missions that I've worked on a study that NASA looked at a study of a mission that would actually leave the solar system. It would use solar sail technology to go all the way out beyond the planets and actually go into beyond what we call the sphere of influence of the sun and go out into the material that's between the stars to see what this interstellar material is like.
Well, now, I'm sensing that there's a little bit of controversy here. Is it kind of like the difference between people that use yachts versus the people that use sailboats?
Yeah, that's a good idea. I like that analogy a lot.
Yeah, okay.
I like sailboats myself, but
anyone
that sails really looks down on the people that use, power boats.
Exactly. So
right.
See, there you go.
Right.
Now, what kind of sail are we talking about? Are we talking about a football-sized sail?
The one mission I talked about that would leave the solar system, that one required a sail that was about 200 meters on a side, so that's about 2 football fields on a side. So we're talking really big pieces of aluminum foil.
And Paulette, how thick is that? How thick is that material?
It's really thin. You're getting so much push on it, so you want it to be as light as possible so it can go faster.
Being made with a thin material, there wouldn't be any problems with solar dust or anything puncturing the sail?
We've looked at that, and you get going pretty fast, and so it's like if a little piece of space dust or whatever, it kind of just makes a little teeny hole and goes right through. Obviously, if you hit something really big, you'd have a big problem.
Right.
Yeah. But that
But
would
you
be.
can't be that unlucky, right? What are the odds that you hit an asteroid?
I like her attitude. That's
That's
great.
right.
A
There
little
you go.
optimism, a
Yeah.
little unlikeliness there.
Yeah.
I think you need to investigate in the NASA Edge logo origami shape.
Oh, now that's a good idea. Little.
Because if you can unfold it and have it in the shape of the NASA Edge logo, it would go beyond the solar system out into interstellar space.
Yes, out
We
to
can
nowhere.
do that.
I have a question I'd like to ask about solar cells. You mentioned how fast, pretty much indicated how fast these solar cells can go. Well, let's say we're in a spaceship that's going really fast, a spacecraft with this solar cell. How in the world do we slow down?
Yes, that's the problem, and that's you've hit it. You've hit the nail on the head, because that's basically why NASA hasn't been as interested in using this technology as an alternative, which is called solar electric propulsion. Because that you can stop. This you basically because once you get out to the outer planets, there's no like radiation pressure anymore because it's falling off, and you can't stop. NASA has a mission called the Dawn. Spacecraft
Right.
Dawn missions going out to visit some asteroids. That's using solar electric propulsion, and that spacecraft has great big solar panels, typical like solar panels you have. And then they take that and they make energy and have a engine, what's called an ion engine.
Right.
And that's how.
Like TIE fighters from Star Wars.
Yeah. They're a little slower than that, unfortunately.
Well, that's the twin ion engine. That's what TIE stands for.
That's true.
Oh my gosh.
Yeah,
Okay.
see?
Oh, we've already done this.
That's right.
It was a long time ago.
We did this back in 77.
No, that was a
It'll-
long time ago in a galaxy
Far away.
Where do you see this solar cell technology 10, 20, 30 years down the road? Do you think it's viable and we can actually have a triple solar sail vessel going
Yeah,
to one of the
right.
outer planets one day?
I hope so. I think, it's the other place that I talked about leaving the solar system. The other thing that we'd really like to use it for is to get a spacecraft that can go in and orbit over the poles of the sun. Because all of our missions that are looking at the sun are stuck in the ecliptic.
Right.
And, it's kind of a limited viewpoint.
Sure.
Because the poles of the sun are different. I mean, we know
Yeah.
that's the poles of the magnet and all.
And being that we're told not to ever look directly into the sun, that's not something you want to do anyway.
And our co-host is stuck in the ecliptic as Edge host, so he can't get beyond that.
Yeah, very limited.
We could have a bipolar spacecraft.
That's
And then it'll need counseling
There you
and
go.
medication.
well. Thank you, Paulette, for being on the show today. We really appreciate you explaining to us more about solar cell technology.
And look forward to a Space Weather Action Center from me later on today. Hopefully in the show, we'll send it to you.
Okay.
Awesome.
And
And don't forget magnetosference.
That's right.
We can talk about that later, though.
if you're gonna put that in a report, put it as a footnote at the bottom of the page.
Okay. Thanks a lot.
Hey, have a great time out in
Okay.
California.
Thanks.
All right. Bye.
Okay. Bye-bye.
You're watching NASA Edge.
And inside NASA, look at all things NASA.
I was waiting for you guys to do that.
You sure were.
What show is this?
Go ahead. Hey, go ahead, Troy. Take the reins on that.
You're watching NASA Edge?
An inside and outside look at all things NASA.
Welcome back to NASA Edge.
An inside and outside look at all things NASA.
He's a pro at this.
Yeah, it's actually a little uncomfortable. I mean, you can at least stutter a little or fumble a little.
I could fumble the ball just a bit. Yeah, I can work on that.
Hey, what'd you think about that solar cell technology?
Awesome. I don't know if you noticed that in addition to being very knowledgeable about the solar sail, she really picked up on magnetospherence.
That all comes back to the sun, which is sort of the focus of the show.
Our favorite part of the
and
show.
especially looking at solar energy and just how beneficial solar energy is for us. Because without the sun, we wouldn't be around. I'm surprised the next 20, 30 years that we're not going to have solar power everything.
We need solar power because have you looked at your energy bill during the winter yet? Man, it's out of control.
Oh, it is out of control. It is.
Excellent point.
Absolutely.
And with the right amount of solar technology, you'll be able to put electricity back into the power grid. Wouldn't
That's
that
right.
be amazing?
Yeah, there's actually neighborhoods around the country where they're actually giving back power and making money. So
Yes, well, I'm sorry, did you say making money? That's very important. That's good. That's reducing the power bill and increasing profit. That's a
Dave Ramsey
double
philosophy.
gain. Yeah, that's right.
That's an economy I can buy into right there.
But anyway, moving on.
We have Sun Earth Day, and Sun Earth Day started as just one event right around March 21st for the equinox. And eventually we found out people from all over the world were using Sun Earth Day activities throughout the year. So now Sun Earth Day has become this huge event that happens with the culminating event on the equinox. However, activities are going on all the time, anytime you can do it. This year, we're focusing primarily on space weather and space weather around the world.
If you need a guest lecturer, I can show
You're
up.
hired. You're hired.
Great.
We'll bring you right in.
Did my mom talk to you earlier?
She did. She's on my iTouch.
Your site is sort of like a one-stop shop about the sun.
That's
and
right.
solar weather. I mean, why go anywhere else? Because your site has everything.
It has, I think, just about anything a classroom or even a museum would be interested in using. Because this year is focusing on space weather,
Right.
we're going to have a whole section on that site that talks about all of these types of space weather and solar energy types of activities you can do as a science fair project or in a classroom.
That might give you an idea for your little...
No, I'm way ahead of you.
No, you're way ahead of me? Okay.
I wanted to tell you and thank you personally because the solar technology I'm using for my Space Weather Action Center was derived from your site. So I went on and actually explored, learned a little bit about solar energy, and I did talk to some NASA researchers afterwards.
That's always a good start.
Because to pull off a full Space Weather Action Center report based on solar power, I needed a little more, power than to boil water.
Solar Week happens a couple times a year. Usually we have it in the spring and in the fall. And it's an entire week of activity that's devoted to the people who go online to register to become part of Solar Week. You can get to that website through Sun Earth Day easily. And on that website, there are several different kinds of activities you can participate in.
Right.
Every day of the week, there's a different theme related to space weather. And this time we'll be dealing a lot with solar energy.
Yeah, I noticed that. Yeah, it was one of the activities. Okay.
And there's information on there for teachers to go into, and they can find all the activities, the games that can be played, and how kids can get involved. One of the really great parts about Solar Week is that they have guest scientists that are there throughout that week.
Oh, that's cool.
And so kids can actually ask questions anytime they'd like.
Is this online?
This is online.
Okay.
If you go to the Sun Earth Day website at sunearthday.nasa.gov, you'll be able to find a Solar Week and also the dates for when that event takes place.
Which is kind of cool is you have a section on solar careers. And that's actually kind of cool because it lets the students know what kind of careers you have in solar energy or solar power. Or
That's right. One day is devoted to kids going online and typing any questions about the science we're talking about or the careers and getting answers right back.
So Blair, do you have? Is there any info here that you've learned in the last few minutes that might help you with your project? Maybe tweak it. Look at other possibilities, different perspectives.
No, actually, I'm all good to go with my space. It's pre-packaged. I put it together. It's just a matter of
so
having
we'll
enough.
present it to Troy. Let's do it now. Franklin, you have it? Do you want to?
There's no better time than the present.
Yeah, let's do that.
Well, there is a better time than the present. There's a time shortly in the future that's going to be much better because like I said, I'm doing this via solar power, and it looks like I'm only at about 70% right now. So when I reach 100%, then I will be able to broadcast my Space Weather Action Center.
Now, the Space Weather Action Center that Blair's talking about is a program that you can also learn how to do yourself on the Sun Earth Day website. And as a matter of fact, I've brought a few little props to show you what Space Weather Action Center is. To do a Space Weather Action Center, you can set it up, build it in your classroom. All you need is a
leisure suit
cloth, a leisure suit.
Sorry.
This is my leisure suit from my mother's that she built for me. But you can basically put this up on the wall or paint the wall green, and you can do some chroma keying with some really inexpensive software.
The green screen.
The green screen, and like they do with the weathermen on TV.
Exactly.
And the ultimate goal is to make something called a space weather report, like you're apparently going to do for us.
Yeah, I don't have a big notebook like that.
Well, let me show you what this big notebook can do for you. This is the Space Weather Action Center notebook. Now, I made this myself like teachers would. You can go to the Sun Earth Day website. You can download a flip chart, and it will actually walk you through how to track a solar storm by yourself.
Done it.
It's pretty easy to do.
I just did the online. I didn't print it all out, but that's exactly what I had to go through to get.
Is this what your report looks like?
No, I actually did. What you're going to see later is the produced video component.
That's perfect, because that's what we're hoping all of our students will do too.
There you go.
And they can make the reports any way they want. It's for them, their classroom, and ultimately we'd love to see students begin to, through their schools, maybe podcast some of the reports out.
Well, how long is it going to take for you to get to the 100%?
Soon, but I don't know.
We gotta go to a break.
Are we getting close there?
We'll go to a break, and but I'm really unsure on the time. But I'll tell you what, The second it's done, I will make sure you get a copy and you can see it and evaluate it and make sure it's up to speed.
Because I have to take off here really soon.
Okay. Well,
and I'll try to take a look as soon as I can. I'm very interested in seeing this.
Perfect. I'm looking forward to it. It should be great.
Hey, so let's go ahead and take a break, and then we'll come back and we'll talk more with Troy offline.
Okay, you're watching NASA Edge.
An inside and outside look at all things NASA.
I'm looking forward to seeing that.
Yeah, I'm looking forward to being a part of the show again.
Yeah.
I need that job link from the site.
Welcome back to NASA Edge.
And inside and
outside at all things.
Go ahead.
An inside and outside look at all things NASA. Thank you, because this is my moment.
You feel better now?
I do feel better.
Because you're back in the chair.
I'm back in the seat.
You're closest to the center, so now you're the co-host.
I feel good again. But I gotta say, it was a great experience to have Troy in the studio today. It was a lot of fun, and of course, we learned a lot.
You know, I covered it for you because you never finished your Space Weather Action Center report.
No, I did. I finished it.
Why didn't you
It's
show
done.
it to me?
No, it's a matter of being able to broadcasting and having the power available to do that.
In other words, you procrastinated.
No.
To hook it up so you can get the power.
No. It just solar power takes longer. Franklin, back me up on this. I mean, I didn't have the industrial solar panels. I had to get scrounge for what I could get. So
I'm just glad to see you back in the driver's seat.
Yeah.
it's great, isn't it? All right. Well, listen. Here's what I'm gonna do.
This aura around you now. It's
the lighting.
Yeah.
It's the lighting off the red hair.
It's a red glow.
But essentially, what I've done, I did the Space Weather Action Center.
Right.
I followed the plans
Okay.
religiously on the website, Sun Earth website. I put together this report. It's powered entirely by solar power.
Okay.
And I'm ready to demonstrate it for you guys. And of course, I am going to make it available for Troy.
You send it to him by email?
Yeah, absolutely.
And you're going to put it on the screen here?
Yeah, absolutely.
Okay.
And as long as you guys are ready, get ready, because this is it. This is my big Space Weather Action
Seen this
Center.
yet?
No.
Yeah. Well, he couldn't have, because I haven't shown it to anybody.
Okay. Let's
So
check
this
it
is all new. Blair Allen with the Space Weather Action Center.
out. All right, let's check it out.
Welcome to the Space Weather Action Center with Blair Heat Miser Allen, the creator of Magnetospherence. Even as a child, the NASA Edge co-host recognized his unique relationship with the sun.
Die, cruel star!
Years later, Blair restored his relationship with the yellow dwarf star and began to use its power for good. Today's entire forecast is powered by the sun. And now, here's your master of Magnetospherence, Blair Allen.
Thanks, brilliant announcer guy, and welcome, fellow solar prognosticators. I'm going to do two things today. First, I'm going to demonstrate my eco-sensibilities by using Troy's leisure suit. Green screen, and I'm powering the entire segment with solar energy. Secondly, I'd like to introduce new technology that uses and analyzes solar imagery to provide data that will enable us to better handle the fluctuations in solar activity, solar flares, CMEs, and most of all, magnetospherence. Let's begin, shall we? Image 1. Oh, this is clearly a Class 1 CME, which within about 3 days you can expect minimal magnetospherence. You'll probably drop a call here and there, maybe from an in-law. You think about your SPF with the intensity. You probably can subtract 5 from your sunscreen rating. Pretty manageable stuff. Next picture. Oh, now we're getting somewhere. This is clearly a Class 5 CME. You still have about 3 days to respond, but you're going to feel the magnetospherence. We're talking GPS recalculating on a major scale. 1 minute you're in downtown DC, the next you're 3 miles off the coast of Madagascar with no cell phone service. Next picture. Oh boy, this is much more serious. Like all Class 6 CMEs, speed is a little less predictable. Kids, do not stare into the sun, not even with those little eclipse shoeboxes. Put away the magnifying glass unless you plan on burning a hole to the Earth's core. Plus, you lose all cell phone, GPS, power grids, and sunscreen becomes nothing more than a marinade. Pretty serious stuff. Next image. Oh, that's strange. I don't have any classification for this. Interesting auroras, but it's pretty much the last thing you're going to see before you burst into flames. We're losing power. Wait a minute. Where's my Hertzsprung-Russell diagram?
This is Blair signing off.
Okay, so there's a little bit of difficulty with the solar power, but you get the idea, right? I mean, that's pretty good, right? It's good. It's fine.
Have you sent this to Troy yet?
Yeah, it went up immediately. Once it was green, boom, gone. Troy would support me on this. Email Troy. Troy would back me up on this. That's a fine space weather. It's just the delivery was kind of inhibited.
Hey, if you want to learn more about Sun Earth Day and Solar Week, go to
sunearthday.nasa.gov.
At least you were paying attention to that segment.
Yes, of course.
sunearthday.nasa.gov.
And if you didn't like my Space Weather Action Center, you can do your own and submit it on the website to Troy, and then he'll judge. And then
Actually, email us at nasaedge@list.nasa.gov and give us your opinion about his SWAC, or Space Weather Action Center.
Yeah, and
report.
it's because it's very important for my future, because if I'm going to be a medianaut, my role is going to be making sure that we don't fly during Magnetospherence.
Okay, whatever. Hey, you're watching NASA Edge.
And inside and outside, look at all things NASA. I beat you. I'm first.
Such a chump.
Dude, you
do that?
You better D up.
No, I'm fine. I told you, it's a power requirement. That's the problem. Isn't the content of the.
This is the guy that came up with magnetosference?